Hello and welcome to VitoshAcademy. Today we will be looking for the derivative of the function y equals logarithm of 1 minus x over 1 plus x. So in order to do this, we would be using the chain rule pretty much. So what the chain rule says that in order to find the derivative of this function, we should know that it is divided into two other functions, outer function, the logarithm, and inner function, 1 minus x over 1 plus x. So the chain rule looks like this. For derivative of the function h, let's call the whole function h, of x is equal to the function f to its derivative. This is the derivative sign, g of x times the derivative of the inner function, pretty much g of x. Here it's not a derivative, it's just the numbers. So what should we do first? First, in order to solve it, we should identify the outer and the inner function. So the outer function pretty much is this one. And we are saying that 1 minus x, 1 plus x is equal to u, just to make sure. And the inner function, we'll call it g, and it would be g of x. It would be equal to 1 minus x over 1 plus x. Pretty much that's it. So the second thing that we should do is to differentiate the outer with respect to the inner. So we are going to differentiate this one. What does it mean? Pretty much f prime of u, this is the derivative sign, is this one is equal to 1 over u. Why is this? This is because pretty much this is like a general rule. Like this. Yeah, this is a rule. Okay, so the next step with the function is to differentiate the inner function with respect to x. So this one, we can see that they're kind of two. So in order not to make mistakes, we're gonna say, okay, we have u and v. This would be u, this would be v. It's a nice name to name them, so let's start. U is equal to 1 minus x, correct? And then u prime would be equal to 1. The derivative of 1 is 0, the derivative of minus x is minus 1. So it would be at the end equal to minus 1. V is 1 plus x. So correspondingly, the derivative of v is equal to 0 plus 1 or 1. Simple as this. So we have defined here the chain rule. We're going to define here a second rule called the quotient rule. And it says that whenever we want to find the derivative of something that looks like this, u over v, then the derivative looks like that. I'm first writing v squared because I shouldn't forget it, and then I write u derivative v minus uv derivative. As simple as this. So we have to replace this one with the data that we have here, and let's pretty much differentiate. So g of x, this is what we are looking for. G of x is equals to, first derivative of u is minus 1, and then we take v. V is 1 plus x. Okay, then we get a minus. And then we get the next thing, u. So we copy the u as it is, 1 minus x. And then I have the v derivative, which is 1, but I'm going to write it just so you can orient yourself. And this would be over v squared, which is 1 plus x. Okay, we open the brackets, so 1 minus 1 minus 1 minus 1 times 1 is minus 1, minus 1 times x is minus x, minus 1 minus times 1 is minus 1, and minus times minus x is plus x, and the times 1 disappears, as it should, and in the end we write 1 plus x squared. So minus x and plus x are gone like this, and then we have minus 2 over 1 plus x squared, which should be minus 2 over 1 plus x squared, which is pretty good. So now we apply the chain rule, this one. How do we apply the chain rule? That's a good question. Let's start with y derivative, and we have first the outer function, the derivative of the outer, which is 1 minus u. So we have the 1 over u. So what is u? U is 1 minus x, 1 plus x. So we simply write it down. Minus x. Don't be afraid of the two lines here. It is going to get better. So then we simply copy g of x, and for g of x, we have minus 2 over 1 plus x squared times minus 2 over plus x squared. Okay, so this one we can solve by putting 1 plus x here. So it goes 1 plus x over 1 minus x. This is because we multiply with the reciprocal of this one here. It's 1 over 1 minus x divided by 1 plus x over 1. And if you imagine the reciprocal of 1 plus x, it goes there. So far so good. And then we have minus 2 over 1 plus x. I'm going to write it like this, 1 plus x times 1 plus x. Okay, what can we do? It's kind of obvious. We can do this and destroy two 1 plus x's, and then it's simplified to something like 2 over 1 minus x, 1 plus x, and this one is an old formula for mathematicians, so it looks like and I shouldn't forget here the minus, actually, because it's important. It's equal to minus 2 over, this is 1 squared minus x squared. 1 squared is 1, I just wrote it so you can get the formula here. And then it goes to the we multiply everything by minus 1, so remove the minus from the 2. So 2 times minus 1 is 1. 1 squared times minus 1 is minus 1. And minus x squared times minus 1 is x squared. So we can simply say that the derivative of y, which is y prime or y, is equals to take to 2 over x2 minus 1. Yes. And we are seeing here with Desmos software that our function is actually already plotted, and we see that on the x range it only takes pretty much values of x between minus 1 and 1, which can actually tell us that its domain is from minus 1 to 1, but the range is on y axis, and the range of y is from minus infinity to plus infinity. And my idea here was to write y prime, so to say. So you have an idea of how our derivative looks like. 2 over x squared minus 1. Okay, I'll remove this one, I'll call it y. And this is how our, okay, I'll call it something like this. Okay, y a, not a good name for a derivative, but here we can call it this way, and this is how our derivative looks like. Yeah. As you see, it has asymptotes, obviously 2 of them horizontal, somewhere around 1, and pretty much that's it. Thank you for watching and enjoy the rest of your day. Goodbye.